Hey guys, Mr. Nadal here with our first math lesson since we started learning at home, and I wanted to start with a really simple review lesson that was also an important core skill. And so this is what I chose: multiplication with area models. And the first problem I was thinking of was, now that we're doing learning at home, I'm also doing teaching at home. And I'm so far producing about 3 videos a day, some complex, some simple. I'll be doing more later, but let's for now use that 3 videos per day. And right now that's taking me about 3 hours to make the videos, post the assignment, do all the related work, and average about an hour a video. So we're looking at 3 hours per day making videos. And at my calendar I looked, and I'm going to be doing this for about 9 weeks. And most weeks are going to have a full 5 days. Not all, but most. So the first thing we need to do is I'd like to change this from 3 factors to 2 factors. So I'm going to go ahead and take that 9 weeks and those 5 days, and I'm going to multiply those together to get the total number of days. So we're looking at 45. Now I'm going to go ahead and make my area model. I need to choose one factor to be the length and one to be the width. I'm going to go ahead and take that 45 and decompose it right here. And I'm going to break that 45 into a 40 plus 5. My other dimension will be the 3, my other factor. Let's fill in that area model. And now I'm going to get 2 answers. I'm going to have 2 products. They're part of the product. They are your partial products. Or if you've been in my class, your PP. Now, let's start here. 3 times 4 is 12. 10 times bigger. 3 times 5 is 15. We are now going to take those partial products that came from decomposing one of the factors, and we're going to recompose them. 120 plus 15. 135 hours. So that's a very rough estimate of how much time I will spend at home making, producing, uploading, submitting these videos as parts of assignments. That is certainly not the only way to do this problem. I might also choose to take that 45 and decompose it a different way. Offhand, I'm thinking a 20, and a 5. There's my first 3 factors made from this initial factor, multiplied times 3 on the other dimension. This time I'll have 3 partial products. Let's get those. 3 times 2 is 6, 10 times bigger. This is a repeat. 3 times 5 is 15. Let's add those partial products and get our product. Six plus 6 is 12, plus 1 is 13. 135 hours. That's certainly not the only way to approach this problem. I want to show you what another method might look like. Let's say I took this 3 times 9 times 5 I had at the start of my problem, and I began by multiplying these 2 factors to get a product of 27. Now I'm going to take that 27 and decompose it. I'm going to put it here, and let's take that 27 and decompose it into a 20 plus 7. And you can put it on either axis. So now, let's go ahead and take that 27 times 5. If you look at this factor of 5 right here, this is not a bad way to go because 5 is a very easy factor to multiply by. 2 times 5 is 10, 10 times bigger. 5 times 7, 5 times 5 is 25, plus 2 more 5s, which is 10, gives us 35. 100 plus 35 is 135. So there's more than one way to decompose and multiply the numbers you're working with. Let's look at a different example. I was thinking about my dog and how much time it spends at home alone. And now it spends 0 hours a day alone at home. Someone is already here of the 6 people that live at our house. And normally I think the last person leaves our house at 8:30. And the first person comes home about 2:30. So 8:30 to 12:30 is 4 hours, to 2:30 is 2 more, so that's 6 hours. So normally it spends 6 hours a day at home alone. Now I'm looking at that 3 hours a day that I'm going to spend making videos. And that 3 hours a day over the course of the next 9 weeks is going to be about 135 hours of videos. Well, the dog is 6 hours at home alone, so it's going to be double whatever this answer is. So I'm looking at 135 times 2. Let's go ahead and do that to get the total number of hours my dog would have been home alone over the rest of the school year versus how long it'll spend at home alone now. So we have that 135 hours that we got from the previous problem, 135 hours. And that's doubled because my dog spends 6 hours a day at home alone, and 6 is double this 3 right here. So that's where we got that times 2. All right, let's go ahead and decompose those. I think I'm going to decompose this 135 into a 100, a 30, and a 5. Just breaking it up along place values. I'm going to put that on one axis. On my other axis, my other dimension, I'm going to use 2. We'll get 3 partial products. First partial product, 2 times 100. Second partial product, 2 times 30. Last partial product, 10. Let's add those together. Looking at 270 hours that my dog would have spent by itself, where now it has its pack all together with it. The dog is very satisfied with that change, unlike a lot of the other more stressful things about the situation we're presently in. Let's look at one last problem. All the kids at our house have been getting more and more into skateboarding, especially over the last week. And that's more and more where their money is going to, and where our money is going to during birthdays and holidays. And I'm looking at the deck of a skateboard, the part you stand on, probably lasts the longest. It's the bearings and I think to a less extent wheels, but I'm not sure, that would get replaced more often. And looking at Amazon, a good set of bearings can be had for about $8. A very good set of wheels, not professional level, but perfectly nice wheels, can be had for about $15. So the first thing I'm going to do is actually add those, or multiply, but I want to add those two values together to find the total cost to refurbish a board that we'd be doing every once in a while for all 3 kids. And that's going to be multiplied times 3, the number of kids. So this right here is the cost for the bearings of the skateboard. This is the cost for the wheels. And this is the number of kids in our house. So 8 plus 15, well, 8 is made of a 3 and a 5, so 15 plus 5 is 10, plus 3 is 15. So really I have 15, or 15 plus 5 is 20, plus 3 is 23. So really I have a 23 times 3. All right, let's go ahead and do that problem. I'm going to take that 23 and decompose it. I'm going to do it along this dimension. I'm going to decompose it based on place value times 3. So 20 times 3 is 60. 3 times 3 is 9. 60 plus 9 is $69. To refurbish everybody's skateboard. That's not too much money. It's a pretty good value. If we're paying that much every year, 2 years, depending on how much maintenance it's going to be for those skateboards. And another problem that I think I'll finish with is sometimes our kids want to get higher level professional equipment they don't really need that we'd probably have them spend their own money on. And I wanted to look at the price difference. These are still nice wheels, nice bearings. Nothing wrong with them at all. Will serve all their purposes. But the more expensive ones I was looking up on Amazon, the bearings per pair were $20. The wheels per pair were $42. And let's see what that would cost. So 20 plus 42, we now have 4, 5, 6 tens and 2 ones times 3. Let's decompose one of those numbers. Let's take the 62. Let's break it up by place value times 3. We'll have two partial products. 3 times 6 is 18, 10 times bigger. 3 times 2 is 6. Let's add those together. 180 plus 6, $186. So let's see the price difference on that, $186. Our previous amount was 69. We'll have to regroup. Take my 10, make it into 10 ones. 7 minus 6 is 1. It's a pretty price difference, $117 to get that professional level equipment. So I think we'll stop there. And in your Google Classroom assignment, you are going to have several problems that I give you that you can choose from, or you're going to be able to make your own. And I want you to show your work and show me how to solve that with an area model. And then tomorrow, we'll either do some more complex area models or we'll move into some more abstract models with just numbers, some numerical models. So that's it, and make sure you read your instructions on Google Classroom.